Hi, this is Shannon Henry with System Security 2 ISA 4220 in the fall of 2019, and today I'm going to be discussing databases. First, we'll just talk briefly about what a database is. A database is an organized collection of data. It's an electronic system that stores data to be accessed, manipulated, and updated. Organizations use databases to store, manage, and retrieve information and manage the databases using a database management system. There are many options for database management systems, such as Microsoft SQL Server, MySQL, Postgres, Microsoft Access, and Oracle Database Management. There are two main types of databases, relational and non-relational. First, we'll start by talking about relational or SQL databases. Relational databases are for use cases in which the user has multiple files that contain the same or overlapping information or are on the same topic. A relational database allows each of those files to be updated independently, but also relates the overlapping information from one to another. Information will only need to be updated on one file in the database, not in each individual file. This type of database is particularly useful for something like e-commerce, where a company will have a ton of information about its customers. They will need to store this information in such a manner that it does not duplicate customers. If everything were to be stored in one file, there would be duplicates each time a customer orders something new. And since businesses strive on repeat business, this creates an issue with customers' information. However, a database allows a business to assign each customer a number, and within that number, the customer's information can be updated. Then a number would be assigned to each order with information relating to that order. The information between those two systems would then be related in the database, allowing for a more structured information storage method. Information in a relational database is stored in tables. The tables contain a set of elements. Each piece of data is called a record, and each item in a record is called a field. One piece of data or record is called a row, and each unique field is a column. Typically, one field will be a primary key. The primary key could be something like a product code that uniquely identifies a row in a table and cannot be empty. A unique value is one that cannot be repeated, such as a product name, and any value that is null is an empty field. There's also the ER model, which refers to the entity relationship model in relational databases, in which each entity is a recognizable object and the relationships are how it relates to the other entities. This is a model used to make diagrams for analysis in relational databases. Now we will move on to non-relational databases. Non-relational databases are also known as NoSQL databases, and they are ones that provide data storage that are stored in means rather than in tabular form. Non-relational databases are better at scaling horizontally than relational ones, which makes it easier to add users to the database. This is great for companies that are still growing because then you can still add users as you grow. Because tables do not need to be joined as they do in relational databases, operations will happen much faster in a non-relational database than they do in relational databases. Many non-relational databases are free or open source, and there are many available options. And finally, there is no built-in data integrity in non-relational databases as there is in relational databases. For this class, we will be using the Postgres relational database on our Ubuntu 18.04 LTS server. Here are some hardening recommendations for that Postgres database. When using Trust Security, Postgres will assume that anyone who is authenticated on the machine is allowed to access the databases. This can be changed to non-trust authentication, where each user logging into the database must authenticate first. This can be done by editing the pg_hba.conf file. Next is to use one-way encryption methods when items do not need to be unencrypted. This will add an extra layer of security. These encryption methods are mathematically simple to create, however, virtually mathematically impossible to undo. So using this for information that does not need to be unencrypted later is a good way to ensure security of this information. Hash-based encryption methods such as MD5 work really well for this. Next, only allowing clients to connect to the database server over SSL or TLS is a good way to prevent a man-in-the-middle attack on the server. This can also be edited in the pg_hba.conf file. Next, connection should be prevented to the database from networks that don't require access to the database. Setting the listen address to localhost will cause the operating system to reject these connections. Next, remote access to the database should be prevented or should only be allowed through an SSH tunnel to prevent unnecessary access to the server and prevent access to the server that is unencrypted. Here are my sources, and thanks for watching.